You know, when we talk about making a car more efficient, what comes to mind? The engine, right? Or maybe the battery in an EV, or the tires. But what if I told you one of the biggest secrets to saving energy is hiding right in plain sight on the very front of your car? Yeah, new research is pointing to something we've all overlooked, and it's about to change the game. I mean, it's just a grill, a piece of plastic with some holes in it to let air in. Simple, right? Well, it turns out how your car breathes is a huge deal for its energy use. And today, we're going to dive into some fascinating research that shows how this dumb piece of plastic is becoming a super smart player in the quest for efficiency. Okay, so to really get why the grill is so important, we got to talk about one of the biggest energy vampires in your car. Yeah, your air conditioning. Think about it. Blasting that cold air on a summer day feels great, but it takes a ton of power. In a gas car, that's you burning more fuel. In an EV, well, there goes your range. So you can see why engineers are obsessed with making the AC system sip energy instead of just chugging it down. So let's pop the hood, so to speak, and do a quick tour of how a typical car AC even works. All right, this might look complicated, but the core idea is actually pretty simple. You've got this special fluid, a refrigerant, going around in a loop. First, a compressor squeezes it, which makes it really hot. Then it goes to the condenser, that radiator-looking thing at the front of your car. And airflow cools it back down. After that, an expansion valve lets it expand, which makes it crazy cold inside the evaporator. And that is what chills the air blowing on your face. It's basically the exact same tech that's in your refrigerator at home. Now, for a long, long time, when engineers tried to save AC energy, they looked at two main culprits. First, the compressor. It's like the heart of the whole system. And second, that big condenser fan that helps cool down the hot refrigerant. And look, it makes total sense, right? Those two things use the most juice. But what if that focus was too narrow? What if, by only looking at the obvious power hogs, they were missing a massive opportunity right under their noses? I mean, what if there were other, sneakier parts of the system you could tweak to get an even bigger win? And that, my friends, is exactly where this new research comes into play. And this really lays it all out. The old way of thinking, just the compressor and the fan. But this new, more holistic approach, it adds two totally new things to the mix. Active grille shutters, yep, the grille we were talking about, and the aerodynamic drag of the car itself. So what in the world are active grille shutters, or AGS? Simple. They're basically smart blinds for the front of your car. On the highway, they can close up, making the car slice through the air better, which saves fuel. But when the engine or the AC gets hot, they can open up to let more cooling air in. Now, these things aren't brand new, but here's the kicker. Nobody ever thought to make them part of the AC's control system. They were always separate, until now. Okay, so you've got this cool new idea. How do you actually test it? I mean, you can't just rip apart a car's AC system and hope for the best. No, you do something way smarter. These researchers built what's called a digital twin. Basically, a super detailed computer simulation of the entire car that behaves just like the real thing. They actually used two main models. You've got the VEM, which is the gold standard. Think of it as the hyper-realistic, super complex digital twin. It's the benchmark. Then you have their new baby, the NL model. It's simpler, faster, but crucially, it's the first one to include the physics of the grille shutters and drag. So the big question was, can our new, simpler model hang with the big, complex one? Can it predict what the real car will do? And here's the answer, a big yes. Look at these graphs. The red line, that's the super accurate VM model, our virtual real car. The blue line is their new model. I mean, just look at that. They're practically on top of each other through all these different driving scenarios. That's the proof right there. Their new model is solid, it's accurate, and we can trust what it's telling us. Okay, so we've established the model is legit, but what did it actually find? This is the really cool part. Take a look at this graph of power use. You can see the total power for the AC jumping all over the place as the car drives. But what I want you to focus on is that little dashed green line way down at the bottom. See it? That tiny, tiny line is the entire energy penalty from aerodynamic drag when you open the grille shutters. That's it. Let's put a number on it. Over the whole test, the extra energy cost for opening up that grille was just 1.24%. That's practically nothing. It is an incredibly small price to pay for a massive amount of what is essentially free cooling from the air rushing in. And the researchers themselves put it perfectly. They said that since the energy cost is so small, you can use the grill as a new tool in your toolkit.
You can open it up, get a huge blast of cooling for almost no energy penalty, and then you can tell the real energy hogs, the compressor and the fan, to just chill out for a bit. It is an amazing trade-off.
So, what this really does is unlock a whole new, much smarter way to think about managing a car's energy. It's like a whole new strategy. So step one, need to cool things down? The first thing you do is open the grille shutters. It's your cheapest move. Step two, now that you have all this natural airflow, you can ease off that power-guzzling condenser fan. Step three, and with the airflow and the fan working together, the compressor doesn't have to work nearly as hard. And the result of all that, a way, way more efficient AC system from top to bottom. But honestly, the big idea here is so much bigger than just your car's AC. What this research really shows is a shift in thinking. It's about looking at the entire vehicle as one big, smart, interconnected system, where every single part, even something you thought was simple, like a grill, can work together to save energy. And that just makes you wonder, right? If there's this much untapped potential in a car's grill, what's next? What other supposedly dumb part of a car is just sitting there, waiting for a little bit of smarts to unlock huge gains in efficiency? I don't know about you, but I think that's pretty exciting to think about.